In this unit, we are going to use the R programming language to do a linear regression on the STEAM data that we've been working with throughout this unit. So the first thing we're going to do is we're going to double click on the R icon, and it opens up the program. Now the next thing that we're going to do is, let me go over here to my desktop. I have already created a directory called Workshop STEAM, and in there I have several things. I've got this program which you can download here, but we're going to just start off right now with, and we also have the data. Now the data is a CSV file, so if I double click on that guy, it opens it up in Excel because it's a CSV file. However, just for fun, I converted it to a TXT file so that you can open it up and see what it looks like in its raw format here. So you see that these are all the variables up here, and also all the variables are separated by a comma. Now we're going to read that into R. Incidentally, I also have this other file here, R variables, and it will tell you what everybody is. Like R is the monthly use of steam, and X1 is real fatty acids in storage per month, whatever that is. This is the average temperature. We've been using this one, X7. This is the average temperature, and the number of days, operating days per month. We've been using that one as well. But this is all the variables here. So the first thing you're going to want to do in R, and I already have the program written, so I'm going to just go through it line by line. The first thing that I usually will do is I will set up a path to where my data is. So let's just do that. So we're going to come in here, and I'm going to create a variable called path, and it's going to be pointing to C Workshop STEAM. So there you go. So if I type in path, and it is case sensitive, so if I do path lowercase, R won't know what it is, but path uppercase, there it is. So the second thing we're going to do is I usually also like to create another variable that I like to call file, and this will be the file that we're going to be using. Now in this case I'm going to use the .txt file, but it doesn't matter. And you can see there it is. Now again, this exercise here is just showing you the mechanics of doing the linear regression. There is no way you're going to become an R expert or be functional in this language by watching this video. This is simply going to be one of these monkey see, monkey do kind of videos where you're going to do this and watch how, or I'm going to do it, and then you're going to watch how I do it, and you're going to do the same thing and just alter it for your purposes. You will, as managers or as people working alongside the analysts, they will be using R, but it's nice for you to know it as well. So anyways, so you can see that I've already got these two variables, path and file. Now the next thing that I'm going to do is I'm going to close these guys. I am going to now go to the next thing, and this guy here, set working directory path. What am I doing there? When I set the working directory, that means when I tell R to do something, to read a file or to write a file or whatever, he's going to write it wherever path is. And I've got path already is defined as this guy right here. I could have hard-coded in that path right in there, but I like to usually just use a variable there. So, okay, so now I've set the working directory. The next thing we're going to do is we're going to read in the data file, and this is the command that will do it. So let's take a look. I'm going to read.csv, so we're going to read the comma-separated variable file. R is going to read file, and we've defined file to be this guy right here. Header is true. That's just simply going to tell R that when he sees the header up here, he's going to use these variable names. And then the separator is comma. I could put in, if I had, even though it says CSV comma separated variable, in reality, if I were to have a semicolon or a colon or some other symbol, this guy would read that. So I just put separator equals comma. And he's going to put the data into S data. So if I type in S data, all the data is there. So this is the STEAM data that we've been working with. It has now been read into the R programming language. Now, usually if you have thousands of records, you don't want to type them all out to the screen. So I could type head S data, and he'll give me the first 6 records. Or I could do tail S data, and he'll give me the last 6 records. So that's how I can look at that. So that's what I'm doing right there. Now comes the fun part. We're going to do our linear regression. How do we do that? Well, the command is this. I'm going to, as opposed to typing it, I'm going to just copy it. Now what is this? It says linear model, so he's going to do a linear regression. And what we're going to do is the data file we're going to read in is called sdata. And that's the guy we just read in up here, remember? So we read it in with the CSV. So we read him in. So that's the data file we're going to use. And what we need to do is to tell R that our target variable is y. Remember, y is our target variable. But I have to tell R that this is the data. In theory, I could be looking at different data from different data sets. So what I need to do is say s underscore data $, which says we're going to use this data. We're going to read this value. So this is the data file we're going to read. Then you say squiggle, and then you just put in the variables we were going to try to do, like x1, x2, and x3. So we're going to build a linear regression model using x1, x2, and x3. So let's click on those guys. So this is the mechanics of doing it. So when he builds the linear regression model, he's going to shove the model into this guy here, which I call M1. And if I type summary M1, there it is. This is the output. So you can see that S1 is equal to 1.6383. X2 is, this is the coefficient for that, and X3 is this. This is the significance test, the p-values. So you can see that only X3 appears to be statistically significant here. We can also look at other things, like we can come up here and see that the R squared value is 44% and the adjusted R squared value is 36%. So this is not one of the better models. So that's how you do it. Now let's just make, before we finish up, let's just do the same thing, but we're going to make things a little bit easier. Because it's a pain in the neck to type in this $, this S data $, for all of the variables, what we're going to do is we're going to use a command called attach. And if we attach S data, we don't have to type this anymore, because when you don't tell R what data set we're looking at, he's going to assume it's this guy right here. So I can now do the same thing that I did before, only now we're going to do M2. I'm just going to copy this guy right there. So now we're going to create the exact same model, only we're going to shove that guy into M2. And you see that we have the exact same command up here, only we now have the convenience of not having to put this variable here. So this S data $, we don't have to do that. So I would recommend you just fast forward and do this part right here. Attach your data set, whatever you call it. I happen to call mine again S data. You can call it anything you want. You can call it Fred, I don't care. And then down here you would attach Fred or whatever you name your data set. And then we're going to create a model, and that's it. So let's do that. And M2. So there it is. Oops. Summary M2. There it is. So again, you see 44%, 36%, and there it is. Now, let's just fast forward one more time, and let's do the whole enchilada. Let's do a model with all 9 variables. So M3 is going to be a model with all 9 variables. We'll do a linear model. Y is equal to x1, x2, x3, x4, x5, x6, x7, whatever, 8, 9. And whatever variables you want to put in. So if you didn't want to put x4 in, you would just delete that guy. So there it is. And if I do summary, M3, there it is. Those are all of the variables that in the linear regression model. And you can see that it is the interesting thing. Let me just open this guy up. Here's what came out of Excel. Remember when we did this in Excel for the other discussion board? You can see that the intercept was 1.89, 705, and minus 1.89. So those are the first 3 guys. 189, 705, negative 189. 189, 705, minus 189. So you can see these are the same answers. 92% R squared. We have a 92% R squared. The adjusted R squared, 87. Let's see what we get with R. The adjusted R squared is 87. So these are going to give us the exact same answers as before because it's a linear regression. So this is how you do a linear regression. And just to finish the process up, let's score some new data. So the way you would do that is you use the predict command. So what I could do here is I could take this model. Remember, when we created a linear model, we put it into a variable, M3, M2, M1. So we've got 3 models here. We're going to use model M1, and we're going to score some new data. Well, in this case, we're going to score the old data set. But if I had new data, I could put that guy in there. So I'm going to predict what the steam usage is using this model, and I'm going to score this data, and I'm going to put the answer in here. So when I do that, if I were to type predicted S data, there it is. He's got all 25. I've got a prediction there. Now what I could do here is I could just say I'm going to copy my S data into a new data file. So let's do that. So let me just copy that guy there. And this way, if you hit X, you can see I've got all the data in there. I just don't want to monkey around with my data set. If I want to monkey around with that, I want to create a copy and play with that once, just in case I screw something up. So that's what I usually do as a best practice if I'm playing around in R. If I start messing with my data set, I'm going to make a copy of it. So now I have X here. Now if you remember, this guy here, PS data, has 25 rows of predicted values. So I could do something like this. X, and then I'm going to give it a new column, and we're going to call that predicted using M1. And that's going to equal, what did we call it? This guy right here. Now if I type X now, let's do the first 6. You can see I've got all the data, plus I've got the predicted amount of steam. So in other words, what really happened was this, but I predicted it would be 9.9 pounds of steam. So in other words, I can make a prediction and append it. So that's how it is done in R.